Hello and welcome back to Yeyu Lab. When you want to build AI agents, you generally have two main approaches. The first one is the deep coding. This means writing all the code by yourself, even with the support by the AI coding assistant, often directly using Python's synchronous features to manage background operations. The good side is that you get complete control and can customize every small detail by yourself. The bad side is that it becomes very complex very quickly. Even with the support of the AI coding assistant, you still have to manage this for the project when it's quickly expanding and officially released. The second approach is using no-code or low-code platforms. These are faster to set up and great for simple tasks. You can often drag and drop components to create agent and workflow very quickly. However, they usually come with limitations. For example, when your agent needs custom logic, or if you want to connect to a specific API that the platform does not support yet, you quickly run into problems. So today, I'm going to walk you through the new Python library from Google Gemini ecosystem called GenAI Processors. This library offers a different way to build these agents and assistants by bringing structure and simplicity. It provides constant way to define how data is handled, and from taking input and doing early processing to make model calls and managing the output. It gives you the structured coding experience, but with the full control of Python. So I can say it stands in the middle of the full deep coding and the no-code tools. Let's see, at its core, GenAI Processors treats all the important output as synchronous streams of processing parts, and each part travels through your pipeline with its own information like its type. The stream-based design makes it simple to connect different operations from the basic data exchange to the complex model generation. When you look at the workflow for the idea of building AI applications by this library, it makes the task run efficiently. For example, a data piece generated in one part of the flow can start processing even while the early parts of the flow are still working. The system makes sure output order is relatively to the input, and it aims to give you the first piece of the output quickly. This efficient operation happens without you having to manage complex details. For example, as shown here in the official blog post, you can build a live agent that handles real-time audio and video using the Gemini Live API with just a few lines of code. Very few, you can see that, compared to our previous project. This code shows how input sources and processing steps combine using the plus operator. The system handles the flow from your camera and microphone in the input processor through the Gemini Live API in the live processor, then to audio output working in the play output. So this is a very simple and built-in projects, but if you want to know detail about how many different processors that the system provides, or how to build my own processor and workflow, you can check in the collab notebooks and find a list of examples. And the first one should be the processor intro, which contains the basic usage of different scenario from the simple processor to a very complex multi-thread workflow. Okay, so from this collab notebook, we can quickly understand the core idea of these three terms: processor part, processor, part processor. So it's a little bit weird for the naming, but they are different things and they are connected with each other. The processor part is the basic unit of the data. It's a container for content such as the text, image, and audio, and other structured data. It holds the data itself and descriptive information like its type. And the processor is a processing station. It takes a stream of the processor parts as input and produces a stream of processor parts as output. An example is a processor that connects all the incoming text before summarizing it. And then the part processor is a specialized processor. It acts on one processor part at a time independently, and the library can run these concurrently on many parts, which is very efficient. So here it's also mentioned the confusion of these two concepts. Processing part is a data object representing a single piece of content. Part processor is a processor designed to operate on individual processor parts. Okay, these are the main different concepts. So how you can connect these concepts together to make a final application is located in the later section of this notebook. You can create pipelines by chaining processors together using simple operator plus for sequential processing, which we have seen this in the official blog posts. And also, let's move down. In the parallel execution of part processor, you can run multiple part processor instances in parallel using the // operator. So these are the two operators that you can use for different scenarios. Now let's look at two practical examples that I made to let you more understand how this works and how to use it to help us build AI agents or assistants. Our first demonstration is an interactive blog post generator with images. This demo creates a simple tool where you can type a topic via the text input, and the system will automatically write a blog post about it by using the Gemini model, and generates an eye-catching header image by the model as well. Then saves both the text and image into a new Google Doc in your Google Drive by using these two API. This shows how to take simple text input, produce structured multimodal output to an external platform. The data flow goes through a simple sequential pipeline. The output of one step becomes the input for the next. Let's run the code first. Okay, it's asked me to enter a blog post topic. Let's say Gemini 3 is out. Type Q to quick. Okay, the text generation has been done. The image generation has been done as well. And then both save into the Google Docs. Let's check. Okay, you can see in my Google Doc account, there is a new file titled Gemini 3 is here. Let's see. Okay, this is Gemini 3 is here, the head image, and this is the blog post is created. So that's a very, very basic example that without any prompting techniques, just to see how the processor workflow combines with each other and how the output can be feed into the external API. That's it. Let's see the code. By using GenAI processors, the code will be very neat in well-organized structure. So firstly, you should make sure that you have installed the necessary GenAI processor library with this Google API, that if you are also interested in saving to your Google Doc and Google Drive via this authentication and APIs. And also the Pillow package for saving image data into a file. And the pillow package for the image processor. The Google GenAI is for Gemini model generation. Okay, from the code, you will see the first get user input by defined terminal input function, which is decorated by the processor.source decorator. This turns a simple asynchronous generator function into a full processor that provides data from the user here. And in the text buffer processor, it produces a stream of the data from an external source, the user, rather than changing an existing stream. So you will see in the text buffer processor is a very typical class that for custom processor by inherited the processor object and make the custom init and call function to make sure it can be chained in sequential and can be called correctly. Now let's move to the image generation processor. Is also inherited from processor.processor class. It needs to do two things in its call function. It generates an image based on the incoming text and pass both the original text and the new image to the next step in the pipeline. So it's not just bring its image to the next stage, it also carries the text from the first processor to the next stage as well. You can see we use the Gemini 2.0 Flash Preview image generation model to generate the cover image. You can feel that a processor has full control over the stream. It can collect parts, can hold information, and create new parts. It must pass on any data needed by later processors. So when all the data that pass to the next processors, let's see the next processor that is OR's doc with image processor, which is used to saving all this stuff into a Google Docs via the Google Doc API. I will not go through the detail of how to connect it to the Google Doc and Google Drive API. You can find it in the source code from my GitHub repository and also the Google documentation from the Google Cloud. So you just to know this custom processor handles the Google Doc API, which takes both the block tests and the generates image to create a rich document. It handles the authentication securely using OAuth, which might open a browser for your first-time consent. This processor is targeting to perform a real-world action that creates an output file to an output platform or API. Now, in the main function, we should assemble the pipeline. Before the final assembling, we also create a block writer that can call the GenAI model by using the Gemini 2.5 Flash model to simply give its system instruction to create a blog post based on the topic that we provide and use that model generation output to flow the text into the follow-up processors that we defined before, including the image generator that use the image generator processor, the text buffer using the text buffers processor, and the doc creator that uses the OAuth doc with image processor. And the pipeline is just simply put them together by using the plus operator. And that's it. This example shows a very clear linear workflow combining the custom logic and external AI calls. Now let's see our second demonstration. Here we still use a sequential workflow for this implementation, and we will possibly introduce the parallel processing in next video. So here in this demonstration, it implements the GitHub repository podcast generator. The project is more advanced and multimodal. It takes a GitHub repository URL from the user input, fetches the data, especially for the README file, and writes a short podcast script about it, generates a cover image by using the image generation from Gemini model, and synthesize the script into a multi-speaker audio file by using the Gemini TTS model. And then finally save all these assets, including the text, the image, and the audio file into the local folder. So this showcases handling diverse inputs and outputs and achieving concurrency within a sequential pipeline, which is a chain of processors. However, we will see how asynchronous I/O allows for efficient operating even within this architecture. So let's run this pipeline to see how it works. Now it's asking me to input the GitHub repository URL. Then I enter my own code base in GitHub for the multimodal client by Vita architecture. This is the front end that we designed before to connect to our backend that enabled by Gemini's multimodal live API to make a real-time audio and image conversation. Okay, let's input Q and it starts. Okay, the first script has been saved. The second image has been saved as well. So let's wait for the final podcast audio generation. It will take some time because the TTS processing will spend some time. And also you can see here, we use the Gemini 2.5 Flash to generate the text. We use the Gemini 2.0 Flash preview image generation for the image. And now you can see that we use the Gemini 2.5 Flash preview TTS model to generate the final podcast wave file with around 4 megabytes. So let's see all these assets in our local folder. Here we have the outputs folder that's already saved with this output. So here is the podcast wave. So let's
building smarter UIs with multimodal AI. Welcome back to DevBytes. Today we're thrilled to chat with Guest Name, who's just unveiled something game-changing. Guest Name, tell us about multimodal client Vite. What is it and what problem does it solve for developers?
Thanks. Multimodal Client Vite is a robust front-end template for AI applications. It's built with a modern stack: Vue 3, TypeScript, Vite for speed, Pinya for state, and Element Plus for UI. Its core strength is on their unique AI application interactions seamlessly.
That's fantastic! Cutting down setup time while still offering deep functionality. For anyone building a modern AI-driven interface, this sounds like a dream. Where can our listeners find this template?
It's open source on GitHub. Just search for Multimodal Client Vite. Clone it and start building your next AI masterpiece.
So, okay, that's it. It's very impressive, right? And we can see the script is here and the cover image is also provided here. So it's ready for use, package for your podcast release. Okay, let's finally see the code. In this code, you will find it's much more neat than the previous code because we used several built-in processors that has already implemented the function inside the processor without our duplicate work. So here, you should provide the Google API key for the Gemini usage and also provide the GitHub token if you also need to run this GitHub fetching function. We start with two pre-built processors chained together that including Gemini model processor taking the text and generate the podcast script, and the GitHub processor that handles API call to get the repo's README file. So we don't have to define our own processor for these two purposes. But we still have to generate the image and audio by ourselves. We still have to inherit processor.processor class to create our own header image generation class, which is the processor that takes the script generate an image, and then pass both original script and the new image down to the stream. After that, the Gemini TTS processor is another custom processor that we define to receive those parts, use the script to generate the audio, and then passes the script, image, and the new audio to the final step. So this is a very typical sequential workflow pipeline. So the key here is how these processors handle waiting for the API calls. They use the async IO to thread function, which runs the blocking network request in the background. This allows the Python event loop to work on other tasks, making the application responsive and efficient without a parallel pipeline structure. And here you will see it's very useful call for generate content configure that using the Gemini 2.5 Flash preview TTS model to generate a two-speaker conversation by defining the speaker 1 and speaker 2 to use the different voices. And then the save assets processor is very simple assets that just save all this output into a decent file into your local folder. And finally, we should build the pipeline to assemble all these processors together. The final pipeline is a very clear sequence chain that including the GitHub processor, podcast writer, text buffer, header image, TTS processor, and save assets. So that's almost all about these two demos. Again, for the entire source code, you can find my GitHub repositories link in the description below. You can refer to them to build your own processors and assemble them into a final pipeline to make your own project. That's all for today. If you have questions, ideas, please drop them in the comments below. Thanks for watching. I will see you in the next video.